Okay, today I have the pleasure of speaking with Brian Potter, who is an engineer and the author of the excellent Construction Physics blog, where he writes about how the construction industry works and why it has been slow to industrialize and innovate. And it's one of my favorite blogs on the internet. I highly, highly recommend that people check it out. Brian, my first question is about the Line project in Saudi Arabia. What are your opinions?
Okay, yeah, this will be just in no particular order. One, that it's just, interesting that this country, Saudi Arabia, and the Middle East just kind of in general, is just so willing to just do these big, crazy, ambitious building projects. And just pour just huge amounts of money in constructing this infrastructure in a way that you don't see a huge amount in like the modern world. They do it. China obviously does it huge amounts. Some other minor places, but in general, you don't see a whole lot of countries doing just these big, massive, incredibly ambitious projects. So like on that level, it's like interesting. I was like, yes, glad to see that you're doing this. But like the actual project is clearly insane and makes no sense. I mean, just from like the physical arrangement layout, right? Like there's a reason that cities like grow in like 2 dimensions, right? Like a 1-dimensional city is like the worst possible arrangement for just like transportation, right? It's like your maximum amount of distance between any 2 points. And so, so just from that perspective, it's like clearly crazy. And there's no real benefit to it other than, perhaps in some like weird hypothetical transportation situation where you had like really fast point-to-point transportation, some sort of weird bullet train setup, maybe it would make sense. But there's no reason to build, in general, there's no reason to build like a city like that, right? Like, even if you wanted to build like an entirely enclosed thing, which again doesn't make a huge amount of sense, you would save so much material and effort if you just make it a cube. I would be more interested in the cube than the Line. But yeah, those are sort of my initial thoughts on it. I'll be surprised if it ever gets built. But
the cube, like from the meme about like you can fit all the humans in a cube the size of Manhattan.
Or something like that. Or I mean, yeah, if you're just going to build this big giant mega structure, at least take advantage of what that gets you, which is like minimum surface area to volume ratio, stuff like that.
And why is that important? Is that for temperature and stuff?
This is actually interesting because I'm actually not how sure it would work with a giant single city. In general, a lot of economies of scale come from like geometric effects, whereas something gets bigger, your volume increases a lot faster than your surface area does. So for like an enclosed thing, like a tank or a pipe or something like that, the cost goes down per thing of unit you're transporting because you can carry a larger amount for a smaller amount of material. It applies to some extent with like buildings and construction because the exterior wall assembly is like a really burdensome and complicated and expensive assembly. So for like a building with like a really big floor plate, for instance, that can get like more area per unit per amount of like exterior wall will, like all else being equal, be more efficient. I'm not sure how actually that works with like a single giant enclosed structure, because theoretically on a small level it would apply the same way, like because your climate control is kind of a function of your exterior surface. Like at some level you get more efficient climate control if you have a larger volume and less area that can escape from. But for a giant city, I actually don't know if that works, and it may be worse because you're generating so much heat that it's now harder to pump out, like the urban heat island effect and stuff like that, where these cities generate like these massive amounts of like just waste heat. I actually don't know if that would work if it applies the same way. I'm trying to reach back to like my physics classes in college, and so I'm not sure the actual mechanics of that. But in general, that's why you would want to perhaps build something of this size and shape.
What was the thought process behind designing this thing? Because like Scott Alexander had a good blog post about the line where he said, presumably the line is designed to take up less space and to use less fuel because you can just use the same transportation across the line. But like the only thing that Saudi Arabia has is space and fuel. So like, what is the thought process behind this construction project?
So I get the sense that a lot of Midis, they've had some amount of success in building like big, impressive physical construction projects that are just like an attraction just by virtue of like their size and impressiveness. Like a huge amount of stuff like in Dubai, right, is something in this category. And they have that giant clock tower in Jeddah that is like similar, like, biggest giant clock, building, one of the biggest buildings in the world or whatever like that. So like, I think on some level they're expecting they can just see a return just from building something that's like really impressive and the biggest thing on some particular axis or whatever. So it could be, there's some extent where I think they're just optimizing for like big and impressive and maybe not diving into it more than that. There's this theory that I think about every so often that's called like the garbage can theory of organizational decision making, which is that basically the choices that organizations make are not the result of any particular recent process. They are the result of whenever a problem comes up, they reach into the garbage can of like potential solutions. And then whatever they pull out of the garbage can, that's what the decision that they end up going with, regardless of how much sense that it makes. It was a theory that was invented by academics to describe decision making in academia. But I think about that, especially with like big bureaucracies and governments. I think about that a lot. Where you can just imagine the horse trading process and like how these decisions just evolve. You can just imagine that any random decision, especially when there's such a disconnect between like the decision makers and like the technical knowledge and stuff like that.
Yeah. Tell me about your eBay arbitrage with designer clothes.
Oh man, you really did dive deep. Yeah, so this was a small business that I ran for a few years, 7 or 8 years ago at this point. Basically, a hobby of mine was just high-end men's fashion for a while, which is a very strange hobby for an engineer to have, but there you go. And basically that hobby centers around, for the enthusiasts of it, it kind of centers around like finding stuff for cheap, because buying it new can just be like overwhelmingly expensive. But a lot of times you can get it for very cheap if you're even a little bit motivated. Either it shows up on eBay or it shows up in thrift stores if you know what to look for, especially because a lot of these clothes and things like that, they can last, because they're well made, they can last like a super, super, super long time. And so even if somebody who has worn it for 10 years or something, it might be fine. So a lot of this hobby centers on finding like ways to get this like really nice stuff for cheap. And a lot of it is based around eBay, but it was really tedious to find really nice stuff on eBay. You kind of had to like manually search like a bunch of different brands and then filter out obvious bad ones and search for like typos in brands that were like pretty reliably put in titles and stuff like that. And so I was in the process of doing this, like, this is really annoying. I should figure out a way to sort of automate this process. And so I made a very simple web app that basically you would search for like, shoes or something, and it would automatically search like the very nice brands of shoes, all the typos in the brand name, stuff like that. And it would just filter out all the junk and let you search through like the good stuff. And then I put I set up a affiliate system basically. So anybody else that used it, I would get like a kick of the sales. So while I was interested in that hobby, I ran this website for a few years, and it was like reasonably successful. It was one of the first things I did that like got any real traction on the internet, but like it was never successful in proportion to how much effort that it took to like maintain it and update it and stuff like that. So kind of as I moved away from the hobby, I eventually stopped putting time and effort into maintaining the website. I'm curious as to how you even dug that up.
I have a friend who was with you at the Oxford
gotcha.
The Refuges conference. Connor Tabarrok. Nice. I don't know if you remember him.
Nice.
Yeah. No, finding other information about you on the internet actually was quite difficult. Somehow managed to maintain your anonymity. So, and then if you're willing to reveal, what was like the P&L of this project?
Oh, it made maybe a few $100s a month for a few years. But I only ever ran it like as a side hobby business, basically. Gotcha. So in terms of like time, effort, per my effort or whatever, I'm sure it was like very low, pennies an hour or something like that.
So a broad theme that I've gotten from your post is that the construction industry is plagued with these lossy feedback loops, a lack of strong economies of scale, regulation, and then cost mistakes being very costly. Do you think that this is a general characteristic of many industries in our world today, or is there something unique about construction?
Interesting question. I mean, that's kind of one thing that you think of is there's a lot of like individual factors that are not unique at all, right? There's like, construction is highly regulated, but it's not necessarily more regulated than like medical devices or like jet travel or even probably cars to some extent, which are very, have a whole battery of performance criteria that they need to hit. So, and like, similar with like coupled to like land use or something like that, people say like, oh, it's, the land requirements and have to build it on site, make it difficult. But there's a lot of things that fall into that category that, again, don't really share the same, structure of how the industry works than construction does. So kind of it's the, I think it's just kind of the interaction of all those effects. One thing that I think is perhaps underappreciated is that a building is like really, and then again, this is not unique either, but a building is really highly coupled in a way that the systems of a building are really highly coupled in a way that a lot of other things aren't. If you're manufacturing like a computer or something like that, right? The hard drive is somewhat independent from the display, it's somewhat independent from the power supply. I mean, these things have coupled, but they can be built by independent people who don't really necessarily even talk to each other and assembled into one structured thing. A building is not really like that at all. Every single part affects every single other part for the most. In some ways, it's like biology, and so it's very hard to change something that doesn't end up disrupting something else. And part of that is because the job that a building does, which is to create a controlled interior environment, basically every single system has to run through and around this sort of surfaces that are creating that controlled interior. So everything is like kind of touching each other. And again, that's not unique. A plane or anything really highly engineered, an iPhone kind of shares that to some extent. But in terms of like the size of it and the relative small amount that you're paying in terms of like unit size or unit mass or something, it's quite low.
Is the fundamental reason you can't like have as much specialization and modularity is that basically transportation cost?
Yeah, I think it's really more just the way a building is, right? Like you can't, for example, for the electrical system of your house, you can't have like a separate box that is your electrical system that you would just install. And if you needed to replace the electrical system, you could take the whole box out and put the new box in. The electrical system runs through the entire house. Same with the plumbing, same with like the insulation, same with, the interior finishes and stuff like that. There's not a lot of like modularity in like a physical sense.
Gotcha. Okay. Now, Ben Kuhn had this interesting comment on your article about why it's hard to innovate in construction, where he pointed out that many of the reasons you give for why it's hard to innovate in construction, like the sequential dependencies and the highly variable like delivery timelines, that's also common in software where Ben Kuhn works. So why do you think that the same sort of stagnation has not hit other industries that have superficially similar characteristics like software?
How I kind of think about that is that you kind of see a similar structure in anything that's kind of like project based or anything where you're kind of having to like, there's an element of figuring out what you're doing while you're doing it, compared to like a large scale manufacturing option, right? You spend a lot of time figuring out what exactly it is that you're building. And then you spend a lot of time designing it to be built. And then, your first number of runs through it, right? You tweak your process to make it more efficient. But at some point, and there's always an element of like tweaking it to make it better. But to some extent, the process of like figuring out what you're doing is largely separate from like the actual doing of it yourself. For a project-based industry, it's not quite like that. You're kind of having to build your process on the fly while you do it. And of course, there's best practices that shape it, right? Like for somebody writing a new software project or anything other project-based, right? Like making a movie or something like that. They know roughly how it's going to go together, but there's going to be a lot of unforeseen things that kind of come up like that. I think the biggest difference is that either those things can often scale in a way that you can't with a building. Like once you're done with a software project, you can deploy it to 1,000 or 100,000 or 1 million people, right? Once you finish making a movie, again, you can 100 million people can do it or whatever. It doesn't quite look the same with a building. You don't really have the ability to like spend a lot of time up front figuring out how this thing needs to go. You kind of need to figure out a way to get this thing to go together without spending a huge amounts of time that maybe would be justified by the size of it. And yeah, he's definitely right. I mean, I was able to dig up a few references for software projects and how often they just have these big long tails of sometimes they just go massively over budget. A lot of times they just don't get completed at all, or whatever, which is shocking. But because of how many people it can then be deployed to after it's done, the economics of it are slightly different.
I see. Yeah. There's a famous law in software. I forget the name of it, which is that a project will take longer than you expect, even after you account for the fact that it will take longer than you expect.
Yeah. Hofstadter's law or something like that is what I think it is.
Yeah. But so I'm curious what the lack of scale in construction implies for startups. Like famously in software, the fact that there's zero marginal cost to scaling to the next customer, that's like a huge boon to a startup, right? But the entire point of which is just scaling with like a hockey exponentially. Does that like fundamentally constrain like the size and quantity of startups you can have in construction if the same scaling is not available?
Yeah, that's a really good question. I mean, the obvious first part of the answer is that for software, obviously, if you have a construction software company, you can scale it just like any other software business, right? I think for like physical things, it is a lot more difficult. And yeah, this like lack of like zero marginal cost has tended to bite a lot of startups, right? Not just construction ones, but yeah, it's definitely a thing. Construction is, I think, particularly brutal because the just margins are so low. And then just the empirical fact that trying what seems like it would be a more efficient method of building doesn't actually let you do it cheaper and like get better margins. Like the startup that I used to work at, Katera, their whole business model was basically predicated on that. We'll just build all our buildings in these big factories and get huge economies of scale and reduce our costs and then make the billions of dollars that we're pumping into this industry or to this business. We'll be able to recoup it. And the math just does not work out. You can't build, in general, you can't build cheap enough to kind of recoup those giant upfront costs. A lot of businesses have kind of been burned that way. And the most success you see in like prefab type stuff is like on the higher end of things where you can get higher margins. And so a lot of these companies, these like prefab companies and stuff like that, they tend to target the higher end of the market where there is and you kind of see a few different premiums for that. The obvious one is that if you're targeting the higher end, you maybe have higher margins. And if you're building to a higher level of quality, that's easier to do in a factory environment. And so you end up being like cheaper than, or at least a lot, the delta is a lot different, less enormous than it would be. You can build it a little bit, building a high level quality is easier to do in a factory than it is in the field. So a lot of buildings that are like, or houses that are like built to a really high level of like energy performance, for instance, like need a really, really high level of air sealing to minimize like how much energy this house uses. You tend to see a lot more houses like that built out of prefab construction and other like factory built methods because it's just physically more difficult to achieve that on site.
Can you say more about why you can't use prefabrication in a factory to get economies of scale? Is it just the transportation costs will eat away any gains you get, or is there like what is going on?
Yeah, there's a combination of effects. I haven't worked through all this. This is going to be the next blog post, basically. So
Excellent.
I'll have figured it out more by then. But the very basic, at a high level, is that basically your savings are not that you get from like using less labor or whatever like that are not quite enough to offset your increased transportation costs. One thing about construction, especially like single family home construction, is that a huge percentage of your costs are just the materials that you're using, right? Like a single family home is roughly 50% labor, 50% materials for the construction costs. And then you have development costs and stuff like that, land costs, things like that. And so a big chunk of that you just can't move to the factory at all, right? Like the foundation, you can't really do that in a factory. You could prefab the foundation, but it doesn't gain you anything. Your excavation still has to be done on site, obviously. So a big chunk of that can't move to the factory at all. And for ones that can, you still basically have to pay the same amount for materials. If you were doing it like, theoretically, that wouldn't be true if you're doing like truly huge volume where you could get material volume discounts. But even then, you're probably not looking at like massive savings. So you can cut out like a big chunk of your labor. And you do see that in like factory built construction, right? Like these prefab companies are like mobile home companies. They have like a really small fraction of labor as their cost, which is pretty typical from a factory in general. But then they take out all that labor cost, they still have their high material costs, and then they have this overhead cost of like whatever the factory has costed them, right? And then you have your additional overhead cost of just, transporting it to site, which is pretty limited, and just the math does not really work out in favor of of prefab in terms of like being able to build like dramatically cheaper, right? You can obviously build a building as a prefab using prefabricated methods and build a successful construction business, right? That like many people do. But in terms of like dramatically lowering your costs, you don't really see that.
Yeah. Austin Vernon has an interesting blog post about this, why there's not more prefabricated homes. And then the two things he points out were like transportation costs, and the other one was that people prefer to have homes that have like unique designs or unique features. When I was reading it, it actually occurred to me that maybe they're actually both the result of the same phenomenon. So like, have you heard of like, I don't know if I'm pronouncing it correctly, but the Alkion-Allen theorem in economics?
Maybe. I don't think so.
Basically, it's the idea that if you increase the cost of some like category of goods in a fixed way, like let's say you tax oranges, right? Like add a $1 tax to all oranges, or I don't know, if transportation for oranges gets $1 more expensive for all oranges, then people will shift consumption towards the higher grade variety, because now the ratio of the cost between like the more expensive orange and the less expensive orange, that ratio has decreased because of the increase in fixed costs. And it seems like you could use that argument to also explain why people have like strong preferences for uniqueness and all kinds of design stuff in manufactured houses, which is that since transportation costs are so high, that's like basically a fixed cost. And that fixed cost has the effect of making people shift consumption towards like higher grade options.
I definitely think that's true. I would maybe phrase this as the construction industry makes it comparatively cheap to like deliver a highly customized option compared to like a really repetitive option, right? And so people, it's the ratio between a highly customized one and just a commodity one is relatively small, and so you see kind of the industry built around delivering somewhat more customized options. I do think that this is a pretty broad intuition that that people just desire too much customization from their homes, and that really prevents you having a mass-produced offering. I do think that is true to some extent. I mean, I think one example is this, like the Levittown houses, which were originally built just, in huge numbers of like exactly the same model over and over again. And eventually they kind of had to change their business model to be able to deliver more customized options because the market shifted. I do think that the effect of that is basically pretty overstated. Just empirically, you see that in practice, home builders and developers will deliver fairly repetitive housing. They don't seem to have a really hard time doing that. As an example, I'm living in a new housing development that is just like 3 or 4 different houses copy pasted over and over again in groups of 50. The developer is building a whole bunch of other developments that are very similar in this area. My in-laws live in a very similar development in a whole different state. And if you just look at like multifamily or apartment housing, right, it's like identical apartments, copy pasted over and over again in the same building or a bunch of different buildings in the same development, right? You're not seeing like huge amounts of uniqueness in these things. People are clearly willing to just live in these like basically copy pasted apartments, and it's also quite possible to get a pretty high amount of product variety using a relatively small number of factors that you vary, right? I mean, the car industry is like this, right? Where there's enough customization options where I was reading this book a while ago that was basically pushing back against the idea that the car industry didn't, in the 50s and 60s was just offering a very uniform product. And they did basically the math, and the number of customization options on their car were like more than the atoms in the universe, basically. Just there's so many different options. So like all the different permutations, leather seats and, this type of stereo and this type of engine, if you add it all up, there was just a huge, massive number of different combinations. And just you can obviously customize a house just a huge amount just by like the appliances that you have and the finishes that are in there and the paint colors that you choose and the fixtures and stuff like that. That would not really change theoretically the underlying way the building goes together. So I do think that idea that the sort of fundamental demand for variety is a major obstruction. I do not think there's a whole lot of evidence for that in the construction industry.
Interesting. Now, so I asked on Twitter what I should ask you, and usually I don't get interesting responses from this, but the quality of the people and the audience that knows who you are was so high that actually all the questions I got were really interesting. So I'm just going to ask you some questions from Twitter.
Okay.
So Connor Tavrock asks, what is the most unique thing that would or should get built in the absence of construction regulation?
Yeah, interesting. Unique thing. Yeah, unique is an interesting qualifier. I mean, there's a lot of things that just like should get built, right? Just like huge amounts of more additional housing, or just like creating more land where in these sort of really dense urban environments where we need it, like, places like San Francisco, just fill in a big chunk of that bay. It's basically just mud flat and put more housing on it. I saw a proposal like that earlier. Unique thing is more tricky. One idea that I really like, I read this in the book Where's My Flying Car, but that it's basically crazy that our cities are designed with roads that like all intersect with each other. It just, that's just a crazy way to like structure a material flow problem, basically. And like any sane city would be built with like multiple layers of like transportation where each one went in like a different direction. So your flows would just be massively, massively improved. Yeah. So that just seems like a very obvious one, that if you were building your cities, that's slightly off topic of the question, but if you were building your cities from scratch, right, and had your druthers, you would clearly want to build them in and knew how big it was going to get, right? So you could plan very long term in a way that, again, almost no cities did, but be able to plan so these transportation systems don't intersect with each other, and you have the space to scale them or run as much throughput through them as you need without like bringing the whole system to a halt. There's a lot of evidence that basically says that cities, tend to scale based on how much you can move from point A to point B through them. And I do wonder if you change the way that they went together, you could unlock like massively different cities, or even if didn't unlock massive different ones, but change like the agglomeration effects that you see in cities. If people could move from point A to point B much quicker than they can.
Yeah, I did an episode about the book Where's My Flying Car with Rohit Krishnan, and I don't know if we discussed this, but yeah, that was an interesting part of the book where he talks about like transistor design. Like if you design transistors this way, like can you imagine how slow they would be? Okay, so Simon Grimm asks, what countries are the best at building things?
This is a good question. I'm gonna again sort of cheat a little bit and do it in space and in time, because I think a lot of the most countries that are most interested in doing a good job at building vast amounts of stuff are not ones that are basically doing it currently. I mean, the current answer is like China, right, where they're just building, more concrete used in the last 20 years or whatever than the entire world used in the time before that, right? Just like big, massive amounts of urbanization, a lot of like really interesting buildings and the construction. I mean, just in terms of like raw output, right? You got to get to that. I would also put like Japan in like the late 20th century on there, basically at the peak of like concern, like wonder, like, is Japan gonna take over the world? And they were really interested in building their stuff quite quickly. They spent a lot of time and effort trying to use their like robotics expertise to try to figure out how to build buildings a lot more quickly. So they had these like really interesting factories that were designed to basically extrude an entire skyscraper just going up vertically. And all these like big giant companies developed them. So they had like these many different factories that were kind of trying to do this with all these robotics. Really interesting system that did not end up ever making economic sense, but it is very cool. I think their sort of big industrial policy organs of the government basically encouraged a lot of these industrial companies and stuff to like basically develop prefabricated housing systems. And so you see a lot of really interesting systems developed from these sort of industrial companies in a way that you don't see in a lot of other places. The U.S. basically just from 1850 to maybe 1970, so for like 100 years or something, just building like just huge, massive amounts of stuff, and in a way that like lifted up like huge parts of the economy, right? Like, we spent all this, I don't know how many thousands of miles of railroad track that the U.S. built between like 1850 and 1900, but it was many thousands of miles of it. And of course, needing to lay all this track and build all these locomotives really sort of forced the development of the machine tool industry, which then led to the development of like better manufacturing methods and interchangeable parts, which of course then led to the development of the auto industry. And of course, that explosion just led to even more big, giant construction projects. So you really see that these just sort of being able to build just big, massive amounts of stuff really in this virtuous cycle with the U.S. really advanced a lot of technology and really sort of raised the standard of development just for a super, super long period of time. So those are kind of my three answers.
Yeah, those three bring up three additional questions, one for each of them. That's really interesting. Have you read The Power Broker, the book about Robert Moses?
I think I got like a tenth of the way through it.
That's basically a whole book in itself, a tenth of the way.
Sorry, Robert Caro fans.
No, but I'm like half of the way through, and so far it's like basically the story of how this one guy built a startup within the New York state government that was just so much more effective at building things, didn't have the same corruption and clientelism and incompetence of the Tammany Hall political machine at the time. And, maybe it like turns into tragedy in the second half, but so far it's like, we need this guy. Like, where do we get a second Robert Moses? Do you think that if you had more people like that in government or in construction industries, public works would be more effectively built? Or is that just... is the stagnation there just a result of like other bigger factors?
Yeah, it's an interesting question. Yeah, I remember reading this article a while ago that was complaining about like how horrible Penn Station is in New York. And they're basically saying, yeah, it would be nice to return to the era of like the sort of unbound technocrat, where like these technical experts in like these high positions of power in government could essentially do kind of whatever they wanted to some extent, right? And if they thought something should be built somewhere, they basically had the power to do it. It's just kind of a facet of this problem of just how it's really, really hard to get stuff built in the U.S. currently. And I'm sure part of it is just that you don't see like these really, talented technocrats or whatever occupying these high positions of government where they can get stuff done. But it's not super obvious to me whether that's like the limiting factor, right? I kind of get the sense that they would end up being bottlenecked by some other part of the process, and just like the whole sort of interlocking set of institutions has just become so risk averse that they would end up just being blocked by, in a way that they wouldn't if when they were operating in the 1950s and 60s or whatever.
Yeah, that's interesting. Okay, so speaking of Japan, I just recently learned that they have like a lot of the construction there is that they just keep tearing stuff down every 30 to 40 years and rebuilding it. So you have this interesting series of posts on how you would go about building a house or a building that lasts for 1,000 years. But I'm curious, how would you build a house or a building that only lasts for 30 or 40 years? If you're building in Japan and you know they're going to tear it down soon, what changes about the construction process?
Yeah, that's interesting. I mean, as I'm not an expert on Japanese construction, but I think like a lot of their interior walls are basically just paper and stuff like that. I actually think it's kind of surprising they use for a lot of their homes. Last time I looked, they use like a sort of surprising post and beam construction method, which is actually somewhat labor intensive to do. The U.S. in like the early 1800s used a pretty similar method, and then once we started mass producing dimensional lumber, we kind of stopped doing that because it was much cheaper to build out of 2x4s than it was like big heavy posts that need to be mortise and tenon connections, stuff like that. I mean, I think the boring answer to that question is that you would just build like we build mobile homes, essentially, which is just using pretty thin walls, pretty low end materials that are just gone together pretty, in a pretty sort of, minimal way, which ends up being not that different than the actual construction method that single family homes use, but just even further economizes and tightens the use of materials, where a single family home might use a 1/2 inch plywood or whatever, they might try to use, 3/16 or even an 1/8 inch plywood or something like that. So probably a pretty similar way to the way most single family homes and multifamily homes are built currently, just like with even tighter use of materials. Yeah, which perhaps says something not super nice about the way the U.S. builds their homes.
Okay, so China is the third one here. There's been a lot of talk about a potential real estate bubble in China, that they're building housing in places that people don't really need it, and of course, maybe the demographics aren't there to support the demand. What do you think of all this talk? I don't know if you're familiar with it, but is there a real estate bubble that's created by all this competence in building?
Oh gosh, yeah, I have, no idea. Like you, I've definitely heard talk of it, and I've seen the little YouTube clips of like them knocking down all these towers that it turns out they didn't need, or like the developer can't finish or whatever. I don't know a huge amount about that. In general, I wish I knew a lot more about how things are built in China, but the information, it's in general so opaque, and I generally kind of assume that any sort of particular piece of data that comes out of China has like giant error bars on it as to whether it's true or not, or like what the context surrounding it is. So in general, I do not have an informed opinion about that.
And then this is the second part of Simon's question. Does greater competence in being able to build stuff, does that translate into other good outcomes for these countries, like higher GDP or lower rents or other kinds of important outcomes?
That's a good question. Japan is an interesting example where basically people point to it as a sort of example of, here's a country that builds like huge amounts of housing and they don't have housing cost increases. And in general, we should expect that dynamic to be true, right? There's no reason to not think that housing cost is essentially a supply and demand problem. And if you built as much as people wanted, the cost would drop. Like, I have no reason to not think that's true. There is a little bit of evidence that sort of suggests that the cost of housing will it's just impossible to build housing enough to overcome this sort of mechanic where the cost of it tend to rise to whatever people's income level are. The peak or the sort of flattening housing costs in Japan also parallel when people basically stopped getting raises and income stopped rising in Japan. So I don't have a good sense of if it ends up being just more driven by some sort of other factors. But in general, I expect of the very basic answer of if you build a lot more houses, the housing will become cheaper.
Right. Speaking of how the land keeps gaining value as people's income go up, what is your opinion of Georgism? Like, does that kind of trend make you think that housing is a special asset that needs to be more heavily taxed because you're not inherently like doing something productive just by owning land the way you would be if you like built a company or something?
Yeah, I don't have any special deep knowledge of Georgism. It's one on my list of topics to read more deeply. I mean, yeah, I do think in general, taxing encourages you to produce less of something. For something that you can't produce less of, it's a good avenue for something to tax more heavily. And then, yeah, obviously, if you sort of had a really high land value tax in these places that have like a lot of single family homes in like dense urban areas like Seattle or San Francisco or something like that, that would probably encourage the land to be used a lot more efficiently. So it does make sense. Makes sense to me, but I don't have a ton of special knowledge about it.
All right. Ben Kuhn asked on Twitter, what construction-related advice would you give to somebody building a new charter city?
That is interesting. I mean, I think I would just off the top of my head, I would be interested in if you could really figure out a way to build that would like using a method that have like really high upfront costs, higher than could otherwise be justified. But if you're going to build, 10,000 buildings or whatever all at once, you could really take advantage of that. One kind of thing that you see is that a lot of in the sort of post World War II era is that we're building such just huge massive amounts of housing, and a lot of times building them all in one place, right? Like the Levittown builders were building like thousands and thousands of houses like in one big development all at once. Like in California, it was the same thing, just building like 5 or 10 or 15,000 houses in one just big massive development. And there you end up seeing something like that, where they basically build like this like little factory on their construction site and then use that to like fabricate all these things. And then you have almost like a reverse assembly line where a crew would like go to one house and install like the walls or whatever, and then go to the next house and do the same thing. Following right behind them would be the guys doing the electrical, the plumbing and stuff like that. So like this reverse assembly line system that allowed you to sort of get these things up like really, really fast, like in 30 days or something like that. A house, just thousands and thousands of houses at once. So I think you could, you would want to be able to do something similar where you could, don't just do the construction the way that the normal construction is done. But that's hard, right? Because a lot of the sort of centrally planned city never seems, or like the top-down planned city never seems to do particularly well, right? Like what's the city, Brasilia or whatever, the one that they built in, it was supposed to be a planned city in like the age of like, again, with the, goes back to like the unfettered technocrat who can sort of build whatever he wants, right? A lot of times what you want is something that sort of responds at a low level and organically to sort of the factors as they develop. And you don't want something that's planned totally top down, that's disconnected from all the sort of cases on the ground. And a lot of, with the opposition to Robert Moses and something like that, ended up being that in a certain form, right? Like he's bulldozing through these cities that are these buildings and neighborhoods that he is not paying attention to at all. And so I think, to go back to the question, trying to sort of plan your city from the top down, I don't think that doesn't have like a super, super great track record, right? In general, you want your sort of city to sort of develop a little bit more organically. I guess I would think just really, really good sort of land use rules that are really thought through well and encourage the things that you want to encourage and not discourage the things that you don't want to discourage. Don't have Euclidean zoning or whatever, allow a lot of mixed use construction and stuff like that. So yeah, I guess that's a somewhat boring answer, but probably something like that.
Interesting. I guess that implies that there would be like high upfront costs to building a city, because if you need to like build 10,000 homes at once to achieve these economies of scale, then you would need to raise like tens of billions of dollars before you could build a charter city.
Yeah, if you were trying to lower your cost of construction. But again, that if you have the setup to do that, you wouldn't necessarily need to raise it, right? Like these other big developments were built by developers that essentially saw an opportunity, right? It didn't require public funding necessarily to do it. I mean, it did in the form of like loans, loan guarantees for veterans and things like that. But they didn't have the government to go and buy the land.
Right. Okay, so the next question is from Austin Vernon, and to be honest, I don't understand the question, but you two are too smart for me. But hopefully, you'll be able to explain the question and then also answer it. Hey guys, I hope you're enjoying the conversation so far. If you are, I would really, really appreciate it if you could share the episode with other people who you think might like it. This is still a pretty small podcast, so it's basically impossible for me to exaggerate how much it helps out when one of you shares the podcast. Put the episode in the group chat you have with your friends, post it on Twitter, send it to somebody who you think might like it. All of those things helps out a ton. Anyways, back to the conversation. What are your power rankings for technologies that can tighten construction tolerances? And he gives examples like AR, VR, CNC cutting, and synthetic wood products.
Yeah, so this is a very interesting question. So basically, because buildings are built, manually on site by hand, there's just a lot of variation in what ends up being built, right? There's things aren't there's only so accurately that a person can put something in place if they don't have any sort of age or stuff like that. So just the placement of materials tends to have a lot of variation in it, and then the materials themselves kind of have a lot of variation in them. The obvious example is like wood, right? Where one 2x4 is not going to be exactly the same as the adjacent 2x4. It may be warped, it may have knots in it, it may be split or something like that. And then also because these materials are sitting just outside in the elements, they sort of end up getting a lot of distortion. They either absorb moisture and sort of expand and contract, or they grow and shrink because of the heat. So there's just a lot of variation that goes into putting a building up, and to some extent it probably constrains what you are able to build and how effectively you're able to build it. I kind of gave an example before of really energy efficient buildings, and they're really hard to build in on site using sort of conventional methods because just the air sealing is quite difficult to do. You have to build it in a much more precise way than is typically done and is really easily achieved on site. So I guess in terms of examples of things that would make that easier. He gives some good ones, like engineered lumber, which is like you take lumber and then you grind it up into like strands or chips or whatever, and you basically glue it back together, which does a couple things. It basically spreads all the knots and the defects out so they aren't concentrated, and then it lets you get everything tends to be a lot more uniform when it's made like that. So that's a very obvious one. That's already widespread use. I don't really see that making a substantial change. I guess the one exception to that would be that there's this engineered lumber product called mass timber elements. CLT is a big one, which is like a super plywood, where plywood is made from tiny little sheet thin strips of wood, right? And then CLT is made from 2x4s dimensional lumber glued in cross laminated layers or whatever. So it's instead of a 4x8 sheet of plywood, you have a 12x40 sheet of dimensional lumber glued together, and you end up with a lot of the properties of engineered material, where it's really dimensionally stable. It can be produced very, very accurately. It's actually funny is that a lot of times the CLT is the most accurate part of the building, and so if you're building a building with it, you tend to run into problems where the rest of the building is not accurate enough for it. So even something like steel, right? If you're building a steel building, the steel is not going to be it's not going to be dead on. There's going to be an inch or so off in just terms of where any given component is. And so the CLT, which is built much more accurately, it actually tends to show all these where these errors are that then have to be corrected. So in some sense, accuracy is a little bit of or precision is a little bit of a tricky thing, because you can't just make one part of the process more precise. All that does is, in some ways that actually makes things more difficult, because then it forces, if one part is really precise, that a lot of times means that you can't make adjustments to it easily. And so if you have this one really precise thing, it usually means you have to go make compensation for something else that is not built quite as precise. So it actually makes construction quite, of advancing like precision quite a bit more complicated. AR, VR, I think I'm very bullish on that, assuming, with a big caveat of that, assuming they can sort of just get the basic technology working. The basic intuition there is that, right now, the way that pieces of building is put together on site is that somebody is looking at a set of plans, paper plans, or like an iPad or something that tells them where everything needs to go. And then so they figure that out, and then they take a tape measure or something like that, or like, some other method, and go figure out where that is, mark it on the ground, and then try to sort of get it all put in there precise. So there's all this like setup time that takes and manual location that is really quite time consuming and error prone. Again, there's only so accurate that a guy dragging a tape 40 feet across site being held by another guy, there's only so accurate that process can be, right? And so, yeah, you can. It's very easy for me to imagine just AR or something like that, which would just project exactly where the components of your building need to go. That would just allow you a much higher level of accuracy that you can easily get using manual methods, and then B, just reduce all that time it takes to like manually measure things. So I can imagine it being like much faster as well. So I'm quite bullish on that at a high level. At a slightly lower level, it's not obvious to me if they will be able to sort of get that level where it just like projects it with perfect accuracy right in front of you. It may be the case that like a person moving their head around and constantly changing their point of view, they're never going to be like they're never going to be able to like project these things with like millimeter precision or whatever. It's always going to be like a little bit jumpy, or you're going to end up with some sort of hard limit in terms of like how precise you can project it. I wouldn't bet on that. My sense is that locator technology will get good enough, but I don't have any principled reason for believing that. And then the other thing is that being able to sort of take advantage of that technology would require you to have like a really, really accurate model of your building that like locates where every single element is precisely and exactly what its tolerances are. Right now, buildings aren't designed like that. They are built using a sort of comparatively sparse set of drawings that leaves a lot to sort of be interpreted by the people on site doing the work. And efforts that have tried to make these models like a really, really, really precise, a lot of times have not really paid off. You can get returns on it if you're building something like really, really complex, where there's a much higher premium to being able to make sure you don't make any errors or whatever. But for like a simple building like a house, the returns to it just aren't there, and so you see really comparatively sparse drawings. And so whether it's going to be able to work worth this upfront cost of developing this like a really, really complex, very precise model where exactly every component is kind of to be determined. There's some interesting companies that are like trying to, I think, move in this direction, where they're basically making it a lot easier to like draw these things really, really precisely. That would just be, have every single component of exactly where it is. So I'm optimistic about that as well, but it's a little bit TBD.
Okay, this raises a question that I actually wanted to ask you, which is, in your post about why there aren't automatic bricklayers, it was a really interesting post, and somebody left an interesting comment, which was that bricks were designed to be handled and assembled by humans. And then I think let me just pull this up. You left a response to that, which I thought was really interesting. You said, the example I always reach for is with steam power and electricity. where replacing a steam engine with an electric motor in your factory didn't do much for productivity. Improving factory output required totally redesigning the factory around the capabilities of electric motors. And then, so I was kind of curious, if you apply that analogy to construction, then what does that look like for construction? Like, what is a house building process or building process that it takes like automation and these other kinds of tools into account? How would that change how buildings are built and like how they end up looking in the end?
I think that's a good question. And yeah, I think that's one big part of, one big component of like the lack of construction productivity is everything is designed and has evolved over, 100 years, 200 years or whatever, to be easy for a guy or, person on the site to manipulate by hand. So like bricks are roughly the size and shape and weight that a person can move it easily around. Dimensional lumber is the same. It's the size and shape and weight that a person can move around easily. Kind of all construction materials are like this. And the way that they attach together and stuff is the same. It's all designed so that a person on site can sort of put it all together with as comparatively little effort as possible. And then, what is easy for a person to do is usually not what is easy for a machine or a robot to do, right? You typically need to sort of redesign think about what your end goal is and then redesign the mechanism for accomplishing that in terms of like what is easy to make a machine to do. I mean, the obvious example here is like, it's way easier to build a like wagon or a cart that like rolls than it is to build like a mechanical set of legs that mimics a human's movement, right? That's just way, way, way easier. So yeah, I do think a big part of advancing construction productivity is to basically figure out how to redesign these building elements in a way that is really easy for a machine to produce and a machine to put together. And one, I think, reason that we haven't seen it is that a lot of the mechanization that you see is people trying to mechanize exactly what a person does. So if a person moves like these 2x4s, into place, they're trying to make a machine that will move them before and then nail them together. And to do that, it's like really, really expensive. You need a lot of like really expensive industrial robots that can move exactly the way that a human moves, more or less. And so I think, a lot of like what that kind of might look like is basically something that can be like really easily extruded by machine in something like a continuous process that wouldn't require a lot of like finicky mechanical movements. And something like that. A good example of I think this technology is a technology that's called like insulated metal panels, which is perhaps one of the cheapest and easiest ways to build an exterior wall. And what it is, it's just like a thin layer of steel. And then on top of that is a layer of insulation. And then on top of that is another layer of steel. And then at the end, there's sort of the steel is like extruded in such a way that it can like these inner panels can like lock together as they go. And it's basically the simplest possible method of constructing a wall that you can imagine almost. But then that has like the structural system and the water barrier and the air barrier and the insulation all just in this like one really simple assembly. And then when you put it together on site, it just locks together quick. And of course, it doesn't, there are a lot of limitations to this. Like, if you want to do anything complicated, like add windows or something like that, all of a sudden it starts to look quite a bit less good. But yeah, I think things like that I think are like really easy for a machine to do can be put together with like a lot of like really, don't need a lot of like precision measurement or stuff like that in field. They can just kind of like snap together and actually want to fit together. I think that's kind of what it looks like.
And then what would the houses or the buildings that are built like using this, what would they physically look like? I mean, maybe in like 50 to 100 years, we'll look back on the houses we have today and we'll be like, oh, look at that artisanal creation made by humans. But then what is a machine that is like designed for robots first or for automation first? Like, in what interesting ways would it differ from today's buildings?
Yeah, that's a good question. I'm not especially bullish on like 3D building printing in general, but this is another example of like building a building using like an extrusion process that is relatively easy to mechanize, right? And sort of what's interesting there is that when you start doing that, a lot of these other like bottlenecks become unlocked a little bit. Like it's very difficult to build a building using like a lot of like curved exterior surfaces, like we're using conventional methods, right? Like you can do it, but it's quite expensive to do. But there's relatively straightforward for like a 3D printed building for that to do, right? Like they can build that just as easily like it's a straight wall. And so you see a lot of interesting curved architecture on these things, and you're kind of seeing that in a few other areas. There's a company that can like build like this cool undulating facade or whatever that people kind of like. And yeah, so it kind of unlocks a lot of options. So kind of machines, you know, they're more constrained in some things that they can do, but they don't have a lot of the other constraints that you would otherwise see. So I think you'll kind of see a larger variety of sort of aesthetic things like that. That said, at the end of the day, I think a lot of the ways that like a house goes together or whatever is pretty well shaped to just the way that a person living inside it would like to use. I think Stuart Brand makes this point in
how buildings learn.
There we go. But he basically makes the point that a lot of people try to use, like dome-shaped houses or octagon-shaped houses, which are good because, again, going back to surface area volume, they enclose the space using the least amount of material possible. So, like, in some theoretical sense, are quite efficient. But it's actually quite inconvenient to live inside a building with, like, really curved walls, right? Because, like, furniture doesn't fit up against it nicely and stuff like that. Like, pictures are hard to hang on a really curved wall. And so I think you would see less variation than maybe you might expect.
Interesting. And why are you pessimistic about 3D printers? Or for construction, I mean.
Yeah, for construction. Oh gosh, so many reasons. Not pessimistic, but just there's a lot of unanswered questions. I mean, so the big obvious one is like right now, a 3D printer can basically print the walls of a building. That is a pretty small amount of like the value in a building, right? It's maybe the 8%, 7 or 8%, something like that. Probably not more than 10% of like the value in a building, because you're not printing the foundation. You're not printing like the overhead vertical, overhead spanning structure of the building. You're basically just printing the walls, and you're not even really printing the second story walls that you have in multiple stories. I don't think they've quite figured that out yet. So it's a pretty small amount of value add to the building. And it's frankly a task that is relatively easy to do by like manual labor, right? It's really pretty easy for a crew to basically put up the structure of a house. This is kind of a recurring theme in mechanization, or it goes back to what I was talking about previously, where it takes like a lot of mechanization and a lot of expensive equipment to replace what basically like 2 or 3 guys can do in a day or something like that. It's the economics of it are pretty brutal. But anyway, so right now it produces a pretty small value of that. So I think that the value of 3D printing is basically entirely predicated on how successful they are at figuring out how to like deliver more components of the building using their system. And there's companies that are trying to do this. There's one that got funded not too long ago called Black Diamond, where they have this crazy system, which is like a series of 3D printers that would act simultaneously, like each one building a separate house. And then as you progress, you like switch out the print head for like a robot arm, because a 3D printer is basically like a robot arm with just a particular manipulator at the end, right? And so they switch out their print head for like a robot arm, and the robot arm goes and installs like different other systems, like the windows or the mechanical systems or something like that. So you can figure out how to do that reliably, where your print head or your printing system is like installing a large fraction of the value of the building. It's not clear to me that it's going to be economic, or right, but that's it. Obviously needs to reach that point, and it's not obvious to me that they've gotten there yet. It's really quite hard to sort of get a robot to do a lot of these tasks. It will kind of depend on how successful they are at doing that. And for a lot of these players, it seems like they're actually moving away from that. Like I think in the recent Icon is the biggest construction 3D printer company in the U.S. As far as I know, and as far as I know, they've moved away from like trying to like install lots of systems in their walls as they get printed, and they've kind of moved on to like having that installed separately, which I think has made their job a little bit easier, but it's, again, not quite. It's hard to see how the 3D printer can fulfill its promises if it can't do anything just beyond the vertical elements, which again are really, for most construction, are really quite cheap and simple to build.
Now, if we take a step back and talk about like overall how expensive construction is, how much of it can just be explained by the Baumol cost effect, that like labor costs are increasing because labor is more productive in other industries and therefore construction is getting more expensive?
Yeah, I mean, I think that's like a huge chunk of it. Yeah, labor has not, the labor fraction of it has I think not changed appreciably enough. I'm going to asterisk that because I haven't actually verified that, and I need to. And I'm remembering somebody that said actually they used to be much different. Who sent me some literature related to it. So slight asterisk on that, but in general, yeah, the labor cost has remained just a huge fraction of the overall cost of a building. Things that were like labor is a huge cost of it, right, have like reliably seen their cost continue to rise. I think there's no reason to believe that that's not a big part of it.
Now, I know this sounds like a question with an obvious answer, but in your post comparing the prices of construction in different countries, you mentioned how the cost of labor and the cost of materials is not as big a determiner of like how expensive it is to construct in different places, but what does matter is the amount of government involvement and administrative overhead. I'm curious why those things like government involvement and administrative overhead have such a high consequence on the cost of construction.
Yeah, that's a good question. I don't actually know if I have a unified theory of that. I mean, just basically with any regulation thing, it just, any heavily regulated thing, it just any particular task that you're doing takes longer and is less reliable than it would be if it was not done, right? You can't just do it as fast as on your own schedule, right? You end up being bottlenecked by government processes. It reduces it narrows your options. So yeah, in general, I would expect that to kind of be the case, but I actually don't know if I have like a unified theory of how that works beyond just it's a bunch of additional steps at any given part of the process, each of which kind of adds cost.
Yeah. Now, one interesting trend we have in the United States with construction is that a lot of it is done by Latino workers, and especially by undocumented Latino workers. What is the effect of this on the price and the quality of construction? So if we have a bunch of hardworking undocumented workers who are working for below market rates in the U.S., will this have dampened the cost of construction over time, or what do you think is going to happen?
So I suspect that's probably one of the reasons why the U.S. has comparatively low construction costs compared to other parts of the world. I'll caveat that for residential construction, right, which is single family homes and multifamily apartment buildings. Those are all built in the U.S. out of light framed wood and put together, like you said, by a lot of immigrant workers. And then, because of that, it would not surprise me if those wages are a lot lower than the equivalent wage for a carpenter in Germany or something like that, and that results in the cost of our residential construction, which is very, very low by world standards. I suspect that's a factor in why our costs of residential construction are quite low.
Now, overall, it seems from your blog post that you're kind of pessimistic, or you don't think that different improvements in industrialization have transferred over to construction yet. But what do you think is a prospect of future advances in AI having a big impact on construction? So with computer vision and with advances in robotics, do you think we'll finally see some carryover into construction productivity, or is it going to be more of the same?
Yeah, it would. I think there's definitely going to be progress on that axis. Yeah, if you can wire up your computer vision systems to your robotic systems and your AI in such a way that your capabilities for a robot system are more expanded. Yeah, I kind of foresee robotics being able to take like a larger and larger fraction of the tasks done on a typical construction site. I kind of see it being kind of done in like narrow avenues that gradually expand outward. Like you're starting to see a lot of companies that they have some robotic system that can do like one particular task, but it can actually do that task quite well. There's a couple different robot companies that have these little robots for like drawing wall layouts on like concrete slabs or whatever. So you know exactly where to like build your walls, which is, you would think it would not be like a difficult problem in construction, but it turns out that a lot of times people put the walls in the wrong spot and then you have to go back and move them later, or just basically deal with it. And so, yeah, it's basically a little Roomba type device that just draws the wall layout onto the concrete slab, and all the other systems as well, like where the lines need to run through the slab and things like that. So yeah, I kind of suspect that you're just going to start to see robotics and systems like that just take a larger and larger share of the tasks on the construction site over time.
What do you think of Flow? That's Adam Neumann's newest startup that is backed with $350 million from Anderson Horowitz.
Yeah. I do not have any strong opinions about that, other than, wow, they're really giving him another $350 million, right? Yeah, I do not have any particular strong opinions about that. I will say that was it A16Z? Were they the ones that wrote the check? They make a lot of investments that like don't make sense to me, but I'm not a venture capitalist, so there's no reason to, there's no reason that my judgment would be any good in this situation. So I'm just presuming they know something I do not.
Yeah, I'm going to be interviewing Andreessen later this month, and I'm hoping nice. I can ask him about that.
I would love to hear what that thing. I mean, it may be as simple as like, VC is all about like really high variance bets. There's nobody higher variance than the engine.
yeah.
Then, so Adam Neumann. So, maybe just on those terms, it makes sense.
You had an interesting post about like how a lot of the knowledge in the construction industry is like informal and contained within like best practices or between relationships and like expectations that are not articulated all the time. It seems to me that this is also true of software in many cases, but software seems much more legible and open source, if that makes sense, than like these other sort of like physical disciplines like construction, despite again having a lot of the knowledge contained within people's minds and within like the culture rather than like explicitly codified somewhere. So why do you think that construction seems more closed source than software?
It's interesting. I mean, to go back slightly to our product versus project industry, right? A slightly different way of thinking about that is it's just like craft-based industries versus like, again, like an industrial process, where a craft-based industry, basically you have, and this isn't like a dichotomy, right? This is a spectrum, but in general, like craft-based stuff, there's like an expertise and judgment aspect of it that is sort of pretty well embedded in the process that you can't really well remove it. Any sort of decision at any given point requires an expert or an artisan or somebody who understands like the relevant context and knows how to proceed based on the specific variables in this specific situation, where like industrial process is more like this has been sort of figured out and this is how it works every single time. And just construction is just very, very much on the craft end of the production spectrum, where a lot, the decision of like how to put these things together and how to wire, this building or whatever, it's all left up to the sort of the expertise and the sort of judgments of the people doing sort of the installation. And what that gets you is that, again, it lets you put things together without having to do a very large amount of specifying exactly what you need, right? Like the drawings to specify a house going together, or even something quite complicated, are way fewer than the drawings needed to produce a Toyota Corolla. I'm sure, for instance, So and the cost required, like to do it, like the design cost required to do it is in proportion to how expensive the thing is also much lower as well. Software is perhaps, and again, I'm not an expert on software development, but it's somewhat more legible by response in that the end product is like, it's very clear. You can clearly see every single part of it and how every single part of it touches every single other part. Perhaps I'm overstating that. I'm sure a software could say, well, it's actually really not super obvious how these things work and why they're done this way or whatever. But you can clearly inspect every single part of it and see exactly how it does, what it does and how it connects to the other part of it. You can't really do that with a building. I guess I would also maybe say that this is maybe an interesting question. With a building, it's not necessarily obvious how it got to the point that it did when it was put together. And a lot of times with like physical things, it ends up, even if you have the object, it is unclear what the process was to create it. And so a lot of times what you see is that even with like, this comes up with like industrial espionage, right? Or somebody who's trying to like steal some particular thing or whatever. A lot of times that doesn't help them as much as they would think to try to like recreate it. A lot of times they have to basically go through the entire process of figuring out how to make it. And it takes them just as long to do it as it did the original people doing the development. You saw this with like the development of the atomic bomb, for instance, where like the people who like stole the plans for how to make it, or who had information on like exactly how their system, the bomb worked or whatever, basically took as long to figure out how to make it as the US did. So just a physical object, just the process being used to make it is not necessarily just super legible. It tends to be a little bit hidden. I was going to say that perhaps that is not as true for software, but I actually realized I don't actually know. And it's very plausible to me that you could have some piece of software that was written. I guess I would maybe ask you this question. Is it plausible that you could have some piece of software that was written and then just it be utterly inscrutable as to how it came together, and how you could maybe, duplicate a similar, a similar piece of software? Or is that like a category error?
Yeah, that's a really interesting question. I think there are a lot of examples where if you don't like have the context on why there was built a certain way, you wouldn't understand like what's going on. Like, if you've heard of like fast inverse square root, that's that's
exactly what I was thinking of.
Yeah. For people who are interested, there's like a great YouTube video on this that like goes through it, but basically just like a whole bunch of like, I mean, the guy who created John Carmack is like a super genius, and like, but if you just look at the algorithm, it's a few lines, but you would never understand like why this gives you an inverse square root unless you. So that kind of stuff where it's like if you just saw the code, it's like, well, you would need to go through the mind of John Carmack when he's like goes through like Newton's method and all these other things, and like why this particular like float operation. Anyways, but I guess the advantage software has is the ability to fork. And so you can't like just take a building and then just make an exact replica of it and then just change the part you want to better understand to see what the effect is. Whereas with like a software project, you can just fork it, or you can just make an API call or something, and then like try to I guess this goes back to the modularity thing you were explaining, right? Like try to understand like the specific subcomponent. It's easier with software.
Yeah, that's interesting. You can like you can run experiments on your piece of software to like understand how it works a lot more easily at lower cost than you can with any physical object, right? But especially like a giant building, right? Where who knows?
Right. Yeah. Okay. So let's say some mega corporation, the CEO of some mega corporation is like, Brian, we want to build some really interesting skyscraper building. And, I've talked to the mayor and the governor, and they're willing to get rid of all the building codes. So there's no building codes. There's no regulation. We just want you to build that's like a really cool skyscraper. What is it that you would do that would be like some idea you have for like some innovation or some change? That would like what would you do if you were given this latitude to just build like a really cool building? Oh,
interesting. I would like to see us fulfill the dream of like the early to mid 20th century and build a mile high skyscraper. Like this was what everybody was not everybody, but this was what people saw the development of skyscrapers going in sort of the 30s and 40s and perhaps 50s, Frank Lloyd Wright designed this mile-high skyscraper called the Illinois, presumably back when this was in Chicago, was like a much of a metro of rising importance. Yeah, there's the technology for it exists. I'm aware of other firms who have like designed conceptual buildings this tall, and you haven't really seen anyone do it. Even these people who are willing to clearly build these giant, white elephant projects, basically, nobody has tried to go the distance and build like the mile-high skyscraper. I would like to see us do it.
Interesting. But I mean, you have a really interesting essay in Works in Progress about like skyscraper height. And then, one of the things you talk about is like how like the superlinear increase in like lateral forces and other kinds of impediments to building tall. How would you get over that kind of stuff?
I mean, you basically by throwing a giant amount of money at the problem, basically. I mean, the basic gist of that is like the physical constraints do not allow you to build, a mile in height. It's sort of the economic and legal constraints that sort of stop this extreme construction. And even the economic constraints are significant enough that even in places where there's not legal constraints like China or Dubai or something like that, they still do not build this height because the economics of it are just so brutal. But in this fantasy scenario, a giant stack of money would get devoted to doing this.
A stack of money a mile high. So speaking of which, in that post, you brought up that argument, like that paper from the economist Glazer that like says that we're leaving billions of dollars basically on the table by having this, building height codes because we're just giving up all this vertical space. I'm curious why you think it's the case that these developers don't have any sort of lobbying or political influence to be able to like collect the billions of dollars of deadweight loss that are created by these codes. Like, why aren't they able to like organize politically in a way that like gets rid of these regulations that are helping no one?
Yeah, that's a really interesting question. In general, the strongest construction lobbying group I'm aware of is probably the National Association of Home Builders, which exerts quite a bit of influence to try to keep the cost of building single-family homes low. I'm not aware of anything that exists for large commercial buildings or something like that. Maybe Association of General Contractors or something. I guess my initial guess would be something to the effect of the natural constituencies for like opposing a big project like this are always going to be quite a bit at least as big, if not bigger, than sort of the constituencies that would be able to act for it, right? So like any big giant construction project, even if it had like a lot of developers mobilized to try to support that kind of thing, also would have a large constituency that would exist to oppose it. Basically anyone who lives in the area and doesn't want this giant shadow of a building, or is worried about the congestion that it would cause, or whatever like that. And I guess a sort of paradox with this situation is that the places that need it the most, because their rents are so high, the people that are living there already are going to be financially well equipped to oppose it, right? Like, and in a certain sense, they're losing the most out of it, right? Like if you're making $50,000 a year, you might value the view out of your apartment at like $500. But if you're making $5 million a year, you might value that view, proportionately more, and be willing to expend a lot more to prevent it from being obstructed. So I feel like this sort of mechanism by where places get wealthier and need more housing kind of also creates its own opposition to some extent.
Which is why I think like a co-seam solution to this kind of thing would be optimal, where it's like, if the view is worth more to you than like a apartment is worth to somebody else, then you can just pay them to like not build there. The view is not worth more than like an apartment is probably worth to somebody, right? So you're just like an inoptimal allocation of resources, just based on who has political influence.
Yeah, it's an interesting question. I'm not super confident of that answer. I should look into it. I should look into it more. Why don't developers have better lobbying efforts? It does seem like a unanswered question.
Now, speaking of being able to put projects into a tailspin and add more sclerosis. You just recently published a very interesting and thorough examination of how NEPA works. Do you want to explain what this law is and what its consequences are? And then I can ask you some more specific questions about it.
Yeah, for sure. So NEPA is the National Environmental Policy Act. This is the law that basically requires any major federal government action that might have significant environmental impacts to do a very long and thorough and expensive environmental impact study before anything is done on a project, right? The law gets a large amount of attention because of how long these environmental impacts take to prepare. The average time currently is something like 4.5 years. And in some cases, since the average, half of them are longer than that. The highway administration, for instance, takes on average something like 8.5 years to do an environmental impact statement. And that's before they can build a highway or something like that. So people are perpetually trying to figure out a way to reform this law, basically, such that we would not have to wait years and years and years before building big, important infrastructure projects, basically. So that's the gist of what NEPA is and how it works.
Yeah, you had a really interesting point in the article where you said that by adding this cost, you can basically think of it as like a tax on all major government action. And the effect of a tax is to reduce what you're taxing. And then I thought at the end you had a really interesting argument how like NEPA is an anti-law. Can you explain this argument for podcast listeners?
It's my spicy take at the end that I always have to throw in right at the end. Kind of the basic argument is that the purpose of a law is roughly twofold. Is to encourage something that you would want more of, or discourage something that you would want less of. So, we have laws against drunk driving because we think drunk driving is harmful and we want less drunk driving in our society. And then the second purpose of a law is to basically reduce coordination problems and enable exchanges that might not otherwise be able to take place. That's, the obvious example of this is the government enforces which side of the road you're allowed to drive on, not because one side is inherently better than the other, but because it's good if everybody agrees on which side of the road to drive on. Contract law is in some ways like this. Like, it's good if people will be punished for breaking contracts because that allows people to go enter into them, which allows exchanges that might not otherwise take place. I forget exactly what the example of this, but there's a argument that's made, like the ability of the English government in like the 1600s or 1700s to like basically have to pay back its debts was a really important development because it allowed it to raise money that it otherwise wouldn't be able to, because people could trust that they would be able to get paid back. But anyway, so those are the two rough purposes of a law, and NEPA does not do either of those things. In the first, because NEPA is basically a procedural statement or a requirement, it does not require the government to like weigh environmental concerns especially heavily. Like, it doesn't prevent a big oil and gas drilling project from taking place. Essentially, what it does require is that for any major environmental effects, you just have to document them very thoroughly. And so it's a documentation requirement and notifying the public of what you're doing. But it's it doesn't prevent a major environmental negative effect. As long as you've documented it quite thoroughly, you can kind of do whatever you want. So it doesn't actually, and the evidence is very unclear as to whether it has had on net beneficial environmental effects. And to the extent that it has, I think there's a good argument that it has done so just by making it harder to do anything at all. And then, the other side of this is to create, certainty, solve coordination problems, stuff like that. NEPA actually is very, very bad at this. It creates a lot of uncertainty because of the requirements for doing the analysis are so unclear or constantly shifting, and the definition of what is a major environmental effect has basically changed over time. An obvious example is in the 1970s. it was maybe not obvious that greenhouse gas emissions were a major environmental effect. But now in the 2020s, that obviously is. And so what you've had to do for a NEPA analysis changes over time, which is, of course, fine in that sense, right? But it does mean that it's very unclear when you have to go through the NEPA process. It is unclear how long it's going to take and what is going to be involved, and whether anybody is going to sort of litigate your decision. This is the other sort of big part of NEPA, is that people are basically able to sue people or groups for like not completing the analysis thoroughly enough. They can't permanently stop a project, because all you need to do is basically show that you've documented your things thoroughly enough. And so once you have documented it thoroughly enough, they don't have grounds for stopping it anymore. But they can slow it down. And if they slow it down enough, sometimes the project becomes unattractive and it gets canceled. That's kind of what a lot of these groups hope for. And so it basically, instead of creating certainty and solving coordination problems, it creates all this new uncertainty where people will like very deliberately try to avoid the NEPA process because they do not know how long it will take and how much it will cost to get their project approved. And in some cases, going through the process will take like a very, 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 very long time. And so making like a business decision as to whether like do a new like offshore wind development or, develop a new forest resource or something like that, it's very hard to do any sort of economic analysis, right? If you don't know when your project is going to start, because who knows how long this NEPA process will take.
Yeah, that's so fascinating. All right, so I've got a lot more questions about this. Because your breakdown was really interesting. So one thing is, I don't know if you're familiar with the long-termist movement. Have you come across this?
Vaguely, yeah.
Okay, so one thing that they've like proposed is this is not like a doctrine or anything, but like on the periphery, some idea I saw was that just as we have environmental review, we should have a posterity review, so that you're like analyzing the impacts of your actions on generations way down the line. Like what are the future impacts of your actions, just as we analyze what are the environmental impacts of your actions. What do you think of an idea like that, given the various dysfunctions of the environmental review process?
Yeah, a couple thoughts. So one is just, I feel my gut response is that any additional review is just going to, add additional time and complexity to your process, right? Like everything is like it's a process that takes some amount of time and has some particular chance of success, right? So just adding another thing that is adding basically another filter to this process, it's only going to make the process slower and less likely to succeed rather than more. And then the other thing is just, how do you, and I know I've seen a take like this before, so this is not original at all, but how accurately you're going to be able to sort of predict what your long-term impacts are. Like it's not obvious to me that anybody making predictions in even over the past 20 years would have been able to sort of do so with any degree of precision. It's not obvious you would even be able to get the sign right on that, whether it be net positive or net negative. That's off the top of my head. I could definitely be persuaded otherwise from somebody who has thought a lot more about it. So that is not a strongly held opinion, but that's fine.
Yeah.
That is not my immediate impression.
That would be my critique as well. Like if you think of in the 70s, correct me if I'm wrong, but the technical consensus at the time was that we would hit peak oil by the 90s. And of course, that's because they couldn't predict our ability to find new reservoirs and develop new technologies, right? So that made more oil available to us. So it's just very hard to predict future trends. So I don't know how much that kind of law would help. So let me ask about NEPA. I vaguely hear that in the political deliberation, they're discussing reform to a NEPA. What would your ideal reform of NEPA look like? How would you reform the implementation?
Yeah, I think on a very simple level, I would like to even the playing field. So a lot of these newer energy technologies and have a lot of the same benefits that like the oil and gas has been able to accrue. So like, for instance, oil and gas has a lot of categorical exclusions for like certain drilling operations, and for like, drilling in the Gulf of Mexico, they actually have a lot of NEPA exclusions, which was perhaps one of the reasons that, not one of the reasons, but you can obviously connect that to like the giant Deepwater Horizon accident. And yeah, so basically just giving the technologies like wind and solar and like high, large scale transmission projects, giving those the same benefits that like oil and gas drilling and like your like natural gas pipelines have, would I think be like a massive boon. So just off the top of my head, that's one thing that I would like to see.
Yeah. Yeah. I wonder what you think about this, but like one idea I had like reading the post was it doesn't make sense to me why this is enforced through the courts where anybody can just like bring a lawsuit. Like, shouldn't there be like a single coherent or like bureaucracy whose goal is to figure out like who's messing up and whatnot? Like, I don't know. It seems like a mistake to have this like done through the courts.
Yeah. I mean, I was reading a paper earlier about it, and basically that from like a law review, it's like, yeah, NEPA is like a horribly drafted law because it contains no provisions for like, funding it or with a bureaucracy for like enforcing it or anything like this. And it's essentially through random chance that the courts, when it was passed, it was like a very activist period in the court, and they decided to enforce this provision for the impact statement, which was kind of added just like, not randomly, but added late in the process without a lot of fanfare or consideration. And then that like one little part of it ended up becoming the most important part, because that's what the courts decided to enforce like really, really strongly. But yeah, people are like, yeah, this is not how you would draft environmental protection law if you were doing it from scratch. It's this sort of weird thing that we've ended up with due to path dependency. But yeah, you would want something, a government agency responsible, a sort of an idea that I've seen or heard floated a few times is that you would want something that looked more like the OMB, which basically is charged with like figuring out how much a given law is going to cost or something like that. Like, and you would want something like a bureaucracy attached to it that was just designed to like, figure out the environmental effects of this, that was like decoupled from like the specific agency or whatever. The downside of that is that for something like the, especially for like a really environmental protection statute, is to whether it would be captured by like political interest or not, and either just not enforced at all if it was like a very conservative staffing for it, or just enforced like extremely, extremely vigorously if it was, on the other end of the spectrum. So that's kind of the risk of that. But yes, it's clearly not ideal that the court system is responsible for basically determining this.
Even if there was like a bias in how the law was enforced, if there's a bureaucracy, the benefit is that you can just like fire the guy who's running it if you think he's not enforcing it correctly, and replace him with somebody who you think will enforce it more appropriately. Whereas with like the judiciary, if it's just like dozens of different judges having like independent, like, I guess, opinions of like how this should be enforced, there's nobody who's like responsible that you can say like enforce it differently. You know what I mean?
Yeah, and it actually makes it, because it's the courts, it actually makes it like a little bit hard to change it, because any given change in the provision, you don't actually know what the effect of it is until somebody files a lawsuit referring to it and it works its way through the courts. So there's like, some people think that during the Trump administration, there was some changes to how NEPA worked. Because that's one thing about it, is that a lot of these laws are federal level laws that are comparatively simpler to change. But they changed some of these laws regarding it. And someone was like, yeah, this is, designed to accelerate it. But because it's unsure how the courts are going to interpret them, it's actually going to kind of increase the risk for these projects in the short term until some of these lawsuits make their way through the courts and we know exactly what is required or not, because the court tells us. So yeah, it's a very inefficient system of implementing environmental requirements. And I'm not an expert on this. I don't think it's really how other countries do it. I'm not strongly holding this opinion, extended extra on it. But, a lot of other countries, almost every other country, I think, has something like requiring environmental impact statements, but I don't think it doesn't necessarily mean that that there's like the courts enforcing it via citizen lawsuits is how it's enforced. I think a lot of times, it's done via like a normal government bureaucracy or something like that.
Okay. I was actually just about to ask that, like, countries that have different or no systems of environmental review, do they have speedier and more cost-effective public works? Or do you have data on this, or?
I don't actually know. It would be very hard to separate that out. Yeah, I don't know.
That's all right. And then you had a comment in that post that I found interesting. You said, this uncertainty also makes changing NEPA somewhat risky. Experts have noted, for instance, that rules to accelerate NEPA processes or impose maximum timelines might result in more of them being challenged in court by failing to take the proper quote unquote hard look. Do you want to explain this? Because this was counterintuitive to me.
Yeah. So the requirements for meeting the NEPA requirement, and this is a more general requirement across other things, but you have to take what the courts call like a hard look, where you have to consider these impacts and quite thoroughly. And so the sort of risk is that if you put like a cap, a timeline cap on some of these processes, like it has to be done in a year, and if it's not done in a year, it's automatically approved. It's just an idea you see floated from time to time. The risk is that people will just say, okay, well, we will go and litigate this project immediately, and then when we do, we will say they did not look hard enough at these impacts. And if there was if they can't marshal the resources or something else, like, we needed to study some particular flowering species and it only has a flowering period of 2 weeks in the spring, and we didn't have time to, the time period was up before that happens, then the court, which is a thing that happens in NEPA apparently, which is one of the reasons why they take multiple years, because if you're observing some species or whatever, you maybe need an entire year or more to actually observe it. But if you fail to look at this plant when it was during flowering season, you don't know if it's actually there, and so you haven't considered the impacts on the potentially endangered species or whatever, and the court would say, yeah, you did not look hard enough at this, so go back and do it again. So it's you see that mentioned quite a few times, that timeline caps could very easily backfire by just increasing susceptible to litigation, which would just make these things take longer than they already do. Already, you see a lot of like extra analysis due to risk aversion from these federal agencies. The laws around NEPA actually say that your environmental impact statement should really not be longer than 150 pages, except in extreme circumstances. But the average environmental impact statement is now like 660 pages or something like that. So people are already like going more than what the law says they should do, just out of risk aversion. So if you don't like fix the incentives that are causing this risk aversion, your solution will not work.
I'm curious if you think that there's been a sort of talent drain from physical engineering tasks like construction into software. Has that happened, and has that had an impact on the world of atoms, or like is that just a thing people like discuss on the internet, but it's not real?
Oh yeah, I do think that's almost definitely happening. I mean, this was my constant opinion when I was, working as an engineer, especially when I was like managing younger engineers, right, who were getting paid like comparatively little, and I was always like on the verge of telling them, there's like, why don't you just go learn how to code and go make three or four times as much at a FANG company instead of doing this like fairly thankless work. Frankly, so I think it's very likely to be an issue. In some sense, it's theoretically like self-correcting, right? To the extent of where if the labor moves out of the field and it then gets more expensive, the incentives around it change a little bit, and you're forced to find ways of building things with less labor requirements, or where you can spread your labor development over a larger volume output. So arguably, if the engineers are leaving and engineers are getting more expensive or whatever, you're going to basically find a way like, all right, we need to get more. That's going to push you towards like figuring out how to like spread your engineering effort over like a larger construction volume, which would be like, using more prefab or using, kitted parts assemblies and things like that. So theoretically, to some extent, it is self-correcting. I guess the risk for that is like, if you screen off the top 20% of most talented people or whatever, does that just like fundamentally handicap what your industry is kind of capable of doing? Or does it just, do your incentives kind of push the other way and you try to like even lower your quality even more? I feel like I've heard some people make complaints to this effect with like semiconductor research, how like semiconductor engineering is actually not especially well paid, and it is relatively easy for like semiconductor engineers to go get jobs working in software development. And so you see sort of a brain drain from that. It'd be interesting to see. I think it actually may be correcting to some extent with engineers. Last time I looked, I'm a little bit out of the engineering game, but the salaries for engineers had actually kind of risen quite a bit. A similar risk is, and people in construction are complaining about this constantly, is just the unavailability of skilled labor, where like we talked about, like being able to like do a lot of these tasks requires like skilled expertise and able to do. And you saw a lot of these people leave the labor force during the Great Recession and then not really come back. And people aren't just entering it at the rates that they need to. I think the average age of like a construction worker is like somewhere in the 40s or perhaps 50s. It's like very, very high. And so people are constantly complaining like, I can't get enough labor, there's not enough workers or whatever like that. But of course, this also is just going to push, incentivize finding ways to basically get these buildings built using less labor. I'm a little bit less worried about like potential negative effects from that. I mean, there's a lot of historical examples of like labor constraints developing into labor saving inventions and things like that. Like the history of the U.S. is like that, right? Where we had like a real not nearly enough labor as they need, and so we developed a lot of labor saving machinery, the American system of manufacturing and things like that. I'm a little bit less worried about that on like the skilled labor side, but I could see it definitely having sort of effects like that on the sort of other sides of the industry.
Yeah. And even who's the author of that Global Economic History book? But they made a point that the Industrial Revolution happened in Britain because the cost of labor was highest in Britain because there was a plague that killed off a bunch of people. So labor was really expensive. Yeah, I've heard that as well. I'm not an expert in economic history, and so I'm trying to avoid comment on things that I know like very, very little about. And I guess, the other factor is just that now, as sort of venture capital expands its tentacles into other industries, you're seeing a lot more effort on developing sort of solutions for the built environment. So to some, you're seeing more venture capital money flow into the space. So perhaps that will counteract to some extent. I don't know. Yeah. All right. Final question. Like many years ago, Tyler Cowen was like interviewed by Patrick Collison. And then like one of the things Tyler Cowen said was that there should be more blogs that are just like focused on one particular area or issue, and then just kind of raise the salience of it and help like drive insight and understanding of it. And I feel like you've done that really well with construction and construction productivity. And I'm curious, what other areas would you like to see the blogs that do for their area what you have done for construction productivity, which is just like take a broader view of what's happening, what the trends are, like try to add more insight into potential problems and things like that? Oh, good question. I feel like there's so much about this. I was complaining to somebody the other day that just this, I think a very underrated problem is just this giant civilizational machine that like takes in raw materials and spits out finished goods and services and high quality of life.
nobody really knows how it works, and mostly how it works is like completely undocumented. Does not exist in written information anywhere, and the information that is written down is like maybe in one particular company's, in shared drive or something like that. Like there's the instructions for building like a Toyota or something don't exist in any way, shape, or form, and it might be very hard to kind of recreate that, if you needed to. But yeah, just in general, I would like to see somebody do something similar for like manufacturing, just in general, especially now, because so much of manufacturing knowledge, U.S. knowledge, has been lost because it's moved over to China and other places where labor is cheaper. There's just so much knowledge has been gone, and just how things that get built and manufactured that just isn't written down anywhere, or isn't written down anywhere accessible. And, you see kind of people share like the same small number of resources for how these things work over and over again. I asked a few people who I thought would know about it, like, is there any like book written that actually explains like what it is like to build something, get something built in China, or like what like building things in China are actually like? And they're all like, no, I don't know any source that exists. There's a few blogs that like describe like their particular experiences, which again, it end up being like overly valuable resources, but there's no like general source of available information for how any of that works. So yeah, I just think like documentation of how the civilization machine functions is just wildly under invested in, which I guess is true for documentation in general, right? Like nobody wants to do that because the payoffs are far in the future and uncertain, and the costs are upfront. So it's not surprising to me that it doesn't exist, but I do think that, in general, it seems people are really very interested in understanding how things work. And if you can explain how something works, even if it seems like a fairly niche topic, you can get quite a bit of attention for doing so. So for anybody who works in, manufacturing or like that, I think you would find quite a bit of success if you started writing things about how it functions.
Interesting. Okay, excellent. To listeners who know about manufacturing, do spin up your Substacks. Okay, so this is part 2 of my conversation with Brian Potter. The first conversation was really interesting, and then afterwards, I realized that I had forgotten to ask Brian about this really interesting theory that Scott Alexander and others have written about. And Brian is the perfect person to talk to about this, so I had to inconvenience him and ask him to come on again. But the idea is basically, or the question is, why does modern architecture just look so much more ugly than things that were built 100 years ago or 200 years ago? You would have thought that due to increases into technology and the buildup in new ideas and designs, that things would become prettier. But if you look at like a building that was built in the last 100 years, it just looks like a cylinder or a rectangle of glass and concrete. And if you look at things that were built before, you see like things like, the Sagrada Familia, or like these intricate cathedrals, or even these skyscrapers that have all these flourishes and ornaments and all these decorations. So, Brian, what is going on? Why are things so much uglier now?
Sure. I have a few thoughts on this. I don't know if I have an answer to the actual question, but I can sort of add some context, I think. I'm not necessarily the best person to ask on this. A better person to ask on it would be an architect who can talk about like how, the design and taste has like evolved over the course of, the 20th and 19th century and stuff like that. But also, in general, I don't have like a huge amount of opinion on aesthetics. And to the extent that I do tend to favor the more like, simple, minimalist, clean lines. Like one of my favorite, pieces of construction is this bridge called Salganatovil, which is built in, I think, Switzerland. It's the banner that's on my Twitter account. And it's exactly this. It's like this really simple, minimalist, just really tiny curve of concrete that's like just in exactly in the shape that it needs to be to resist the forces on it. And so to some extent, to me, it's like you're asking, why did aesthetics change from like worse aesthetics to better aesthetics? Well, because they're better. That's obviously not what I actually think, but just again to a little bit where I'm coming from. You want to like separate out the question a little bit. I think it's more a question of why do modern buildings have like less ornamentation, not necessarily that they're like ugly per se. I think there's like a lot of like a really, beautiful modern architecture, and kind of a lot of what it sort of seems to focus on. And again, an architect would be a better person to ask about this, but I will sort of muddle my way through using like light and space and form to like create like these big, interesting, impressive open spaces that like create a lot of just interesting shapes, and like this big expansive space is what they're kind of really going for. A good example of this, like a building I think is interesting, is if you look at like the new terminal for the Portland airport, which has this big giant mass timber roof, which is a way of building these big large span structures, but it's really neat and kind of interesting. And that's like a lot of what kind of you see these a lot of architectures is kind of focused on. And that's been like pretty common throughout history, right? Like cathedrals, it's like they're trying to create these like big impressive spaces using, with like using like light and stuff to create, this impressive space. With like the Pantheon, it's like the same thing. It's like creating this big, open, impressive space. And so I think it's really, you kind of want to separate out to some extent the question of why is it ugly, which I'm not necessarily agree with, and why does it have so much less ornamentation, which I think is like a little bit more defensible.
Okay. Actually, let me ask about the second one, because I'm not sure I totally followed. So the ornamentation has been replaced by the openness?
Well, yes, yeah. So I guess my point is that a lot of like interesting, impressive spaces were just focused on creating this big indoor, impressive, large span space, and using the playing with the light and stuff to do that. And that's been like common in like buildings that people think are impressive, and you still see that today. Architects still do that a lot, right? The using like big open areas with a lot of glass everywhere is kind of a tool in their tool belt to kind of do that to some extent.
Gotcha. So they were replacing like the old stoneworking and stonemasonry stuff with and the gargoyles with these kinds of things. Okay, I see. Okay, so yeah, let's talk about one, because the idea that the older designs were less efficient in some way. To steelman the opposite position, someone might say that a lot of the value of construction and building is just the aesthetic presence that it has in a city or a neighborhood. And to the extent that we've lost that, maybe we got to use less material on a bridge or a skyscraper, but then it kind of just acts as like this, it's just like this ugly thing in the middle of the city. Or if not ugly, at least not as aesthetically pleasant as it could have otherwise been. And that's something we should care about when we're doing construction. How would you react to something like that?
Yeah, so I guess to clarify what I was talking about before, I don't think new buildings necessarily use less material in a sense. I just think they have an aesthetic that's more minimalist and streamlined and without a lot of extra decoration on it. I mean, the complaint is like, all building is a big like circle, cylinder of glass or a rectangle of glass, or whatever like that. I think one reason that is true is because it may not be super interesting from the outside, but if you're on like the inside of a building, it actually is. You actually kind of want like a whole lot of glass. Like it's really nice to have a whole, a large open space to walk through, and to have like a lot of like natural light. That was very hard to do prior to like, the mid 20th century. And because for a couple of reasons. One is because buildings weren't really air conditioned before that.
Yeah.
And another one is like, it was like, really very, very, to have like big expanses of glass. It's still expensive, but it was like even more expensive as you go farther back. There was a glass making process invented in like the 1950s, 1960s called the float glass process, which made it a lot. You could basically make really high quality glass for like way cheaper than it was possible to previously. And so that, and, air conditioning and stuff like that, it basically, and then, advances in like structural design, increased use of like steel, stuff like that. It basically became a lot more possible to just have like your building as like a big giant slab of glass and have like a lot of natural light and a lot of openness on the inside. And that creates kind of a nice experience if you're actually in the building.
I see.
And I think that to some extent applies a little bit more generally. If you look at like, if you look at an HGTV remodel or something like that, everybody wants to create like a big, giant, open concept floor plan or whatever with all the walls blown out and lots of natural light coming in everywhere. So, I mean, to some extent, it's just like the technology. It seems like it's maybe a case of the technology evolved such that you could create this nicer interior space to some extent that perhaps came at the expense of like having a lot of really ornate decoration on the outside, not on the top, but the outside. And, if you're building a building, it makes sense to, optimize the inside at the extent of the outside, because that's what is you're actually using.
Okay. Yeah. That's an interesting way to put it. One comment that I've heard is if the progress of YIMBYism has been hurt by the fact that new buildings, because of this rational self-interest, are ugly on the outside and very pleasant on the inside. But the result is that the people who are I don't know, the community organizers or whatever, the other people in the community will oppose these new buildings because what they get to see is the outside. And, all these historical preservation boards, they will notice that these older buildings that are not as pleasant on the inside and have obviously less occupancy and everything, they look more pleasant in their neighborhood than the new buildings that people want to tear these down and build. And then so if we want to convince the NIMBYs to go along with new construction, you kind of have to make it look beautiful. What do you think about that?
Yeah, I bet it seems like it's true probably to some extent. I mean, that's like the fundamental tension in like real estate, right? Is that any property you have has a lot, has like a lot of externalities and influence the value of everything around it. So like it's this big game of negotiate. Any given thing you build is like a big negotiation between you and everything in the immediate area. And that's why things like zoning and stuff like that exists in the first place, even if it's not, necessarily implemented in an especially way that people think is good. I think it's probably a little bit easy to over-index on that. It would not surprise me if it's like, okay, we'll build this and it's like a really beautiful old building. It's like, no, it's still gonna be a giant building. It's still gonna mess up my traffic. It's still gonna have a bunch of renters that are gonna come in and reduce my property values. You see a lot of these like historical preservation things want to preserve things like old gas stations and laundromats and things that are like not beautiful at all, or like parking lots and stuff like that. So I think that's probably true on some margin. I would be surprised if it's like, this is the one thing we need to fix to untangle this problem.
Gotcha. I wanted to ask, by the way, you mentioned how indoor air conditioning and heating has changed this dynamics. Is it just because you have enough insulation that even if you lose heat through the glass, that's fine? Or
no, I mean, basically, if you have like a glass, a big glass wall on your as your exterior building, right? That like is, if you don't have air conditioning, that thing is just going to like cook whenever it gets hot out. That it's going to basically be like a greenhouse. So you basically need air conditioning to sort of make that habitable. You see this with like single family homes too, where when air conditioning started to become like popular and like installed by default, all of a sudden they started building these houses with like these big giant picture windows, which they didn't have before, which people like, right? Again, this makes like a nice inside space. And if you're going to be inside, that's the part you want to focus on. But again, it basically is predicated on having air conditioner to control the climate.
Gotcha. Okay, so that explains why the outsides of buildings aren't as pretty as they used to be. But there's still the question of why insides are so minimalistic. Like, I don't know if you saw this, by the way. So about a year or two ago, Microsoft announced that they were building this new office for developers in India. And the interior, the outside, it looks like a modern, glass building, but the inside, They had all these like really interesting Mughal architectural details and craftsmanship that made it look, for everything from the furniture to the floor layout to the arches of the entrances was supposed to like look like a Mughal palace, and it actually looks really cool. And so, why don't more developers do something like that on the interiors of these buildings?
Yeah, I mean, again, good question. I think for the most part, a developer is, very broadly speaking, and again, I'm not a developer, so I'm going to muddle my way through it as best I can. They're basically building this space to rent out, right, or to sell to somebody else. So they're creating like a lot of times it's developments called like shell and core, which I think I'm using that correctly, but where they basically don't even like finish the inside. It's all just like raw open studs and everything like that. And the tenant comes in and does whatever they want to the space.
I see.
But they're basically in the business of creating like usable space for some given class of market that they're trying to attack, right? They're not in the business of making fancy architecture. Same if you're buying a single family home, right? You come in with blank walls and you put up all your different pictures that you want and different, decorations and paint it however you want and add your funky wallpaper or whatever. And then when you move, you can take all that stuff out and the next person can come in and put everything that they want. So it's just, I think to some extent you see like a decoupling of the aesthetic design from the building itself.
Okay, so then this is really a revealed preference about the people who are actually renting or buying these properties, that like people who are living there actually don't want this kind of interior design maybe?
Yeah, I think, again, it comes back to a little bit about like a question of like aesthetic style and just like, do people like want a lot of ornamentation and, fundamental attractiveness? Because again, people do focus a lot on like making these spaces like attractive. And a lot of times they do that by like having like big and nice and open, a lot of natural light and like a cool, glass staircase or whatever that goes from here to there. People like the new, somebody pointing to the new, Google headquarters, I don't know how new it is, but on the newer side, basically it's like, yeah, this big giant, like, dome type thing with a lot of like structural detail visible and a lot of like, yeah, just lots of light coming in, this big giant open space, a lot of like interesting staircases and kind of stuff like that. So in some extent, it's just like a style with like less ornamentation necessarily than like bad aesthetics per se.
Okay, gotcha. The other theories that are out there about this emphasize more the cultural and aesthetic changes rather than the actual practical necessities of these kinds of changes that you've talked about. So one theory is that if you look at the change in men's clothing over the last 2 centuries, it's become also much more minimalistic and much less colorful and ornamental, right? So if you look at, a King Louis or something, he's like wearing a suit with all these studded colors and dyes and even gems and stuff. And if you look at like a picture of Joe Biden, he's just wearing a suit, not even a tie anymore, right? It's just a black suit and a white shirt. So that this is a continuation of this sort of aesthetic trend towards being very minimalistic. What's your reaction to that, Sake?
Yeah, I mean, I think that's true to like some extent. This is one of the difficulties having a conversation like that, is that there's so many like degrees of freedom. It's hard to pin down, what specifically you're talking about and what class of things you're specifically talking about. Like if you're talking about, if you look at like an example from fashions, if you look at like streetwear or something like that, if you just Google streetwear or something like that, you will find a ton of pictures of like really sort of quite ornate, interesting clothing that's not there will be some stuff that's minimalist, but there will be a lot that's like not necessarily minimalist at all. So I guess in some way I disagree with the premise. I mean, if you're talking about like some like elite counter signaling thing, like, it's so easy and cheap to make like ornate colorful clothing that it's not like a signal of status anymore. So you have to counter signal by like your very simple clothing. Maybe there's something, to that, but that's like a different thing than like, why are things ugly in general, right?
One thing that people also talk about is the increasing cost of labor, that now you can't hire talented stonemasons to spend hours on every square foot of the outside of a building. So I was in India like 6 months ago, and we went to New Delhi to visit this new temple that was built, the Swaminarayan Akshardham. I'm sure I mispronounced it, but anyway, so it's this really intricate and cool design on the outside. It just covered in these hand carved stones with like these intricate idols and different images, and it's really cool, but I think it took like tens of thousands of hours, probably way more, and like thousands of workers and stonemasons to actually construct that, and which is obviously not going to be very feasible economically in a Western country. So one theory is just that we don't, just too expensive to do that kind of stuff anymore. You need to do something that doesn't require as much manpower.
Yeah, I mean, I think there's that's definitely got to be part of the story, right? I mean, construction, as we know, has not really gotten any cheaper, but it also hasn't gotten more expensive, right? Like a lot of this other, basically things that are pure labor, like other services, right? Like medical care, education, stuff like that, which has gotten more expensive. And part of that is probably because we've found ways to like pull labor out of the process. So construction only rises at the rate of inflation instead of faster than the rate of inflation. And yeah, so like super labor intensive things like masonry that just, gets done anymore. And there's probably like a vicious cycle there where, you hire less of it. And so there's fewer masons available. And so they get more expensive and the skill gets more scarce. And now it's to hire someone to do like really ornate masonry work in the US is probably really difficult to like even find them. I'm sure they exist, but it's probably not trivial. And if you're like, have your schedule you're trying to meet, it's not super straightforward. An interesting example of this is, I can't remember if we talked about this in part one or not, but the Ise-Jingu temple in Japan, which is this temple complex that they've been like, it gets like torn down and rebuilt every 20 years. And they've been doing this for, like 1300 years or something like that. So it's using like 1300-year-old, construction techniques, so like, thatched roofs and like particular woodworking methods or whatever. And it's now like quite difficult for them to find a lot of these skills, right? There's just not that many roof thatchers around anymore. It's so, again, I can imagine that like, it was some sort of a similar cycle with masonry. I don't think that's like the whole story, because a lot of these things are kind of built in a way that like make buildings, a lot of this like minimalist style is actually quite expensive to do. A glass curtain wall is actually really expensive to build on a building because it lets in because glass is just expensive by itself, and because it lets in so much light and it gets so hot and you need so much more, a more expensive mechanical system to keep it cool. But I've talked to architects like, why do the owners love these, glass curtain walls? It seems like, especially for like now where like everyone is like really concerned about like climate change and, greenhouse emissions of your, whatever it is you're building. People are like, yeah, owners just really love this all glass look, and they're willing to sort of pay extra to get it. And if you look like the very early, this is the sort of style of construction where you just have a big glass facade. It's called, for like a skyscraper, it's called the international style. And you see like early international style skyscrapers, they were actually quite expensive, more expensive than the traditional way of building. But again, the people who were like building it really liked the aesthetic, and again, it gave you some other options in terms of like light on the inside or whatever. So it was they decided that it was worth it. So I think, yeah, that's definitely probably part of the story. But again, I think definitely doesn't seem like it can be all of it.
Gotcha. Okay. Yeah, to the extent that it is part of the story, somebody left an interesting comment on one of Scott Alexander's posts on this thing about how modern construction looks different than older construction. So this is a comment from Fluffy Buffalo. He writes, or he or she writes, I think new technology should help a lot with 3D painters, CNC machines, robots, CAD, and AI. It shouldn't be too hard to come up with a way to produce eye-pleasing ornaments, murals, and building shapes at a reasonable price. And then they go on, but no one is doing it because the current crop of architects can apparently only think in steel, concrete, and glass. So how plausible do you think this is?
Yeah. So, I mean, that makes me think of, and I think I read some of the comments on that post, and I think one of the people mentioned that. But like, yeah, the Victorian style of house basically came about because of mass production methods, which made like really ornate wood decorations to, you could make those like really, really cheaply, just like they were just cranked out on some milling machine in a factory somewhere, and then you could just buy them and staple them to your house or whatever. And so that style is basically a function of technology making that cheaper. And then of course you don't, that was in style for a while. It's not in style anymore. Shifting sands of aesthetics, but also I think part of it is that, and this is, I think, more broadly applicable, it's actually kind of a hassle to have all this like ornamentation all over your house or whatever. On the inside, it's just lots and lots of stuff to like dust and keep clean or whatever, which again comes back to cost disease. If you have servants to do that for you, it's fine. But if you don't have servants, it creates a lot of extra work for you. Same on the exterior, but then also there is the issue that in general, you want your building to like shed water and, direct it away from the house as possible. If you have a lot of like little nooks and crannies and ornamentation stuff for water to collect, that's pretty bad from a durability perspective. I would be careful not to over-index on that, because obviously you can build like, and people did build like extremely durable, beautiful masonry brick buildings, right? It's not like that makes it impossible, but it is something to like consider, that it does on the margin probably make your maintenance costs go up.
Okay. Are you optimistic overall? Maybe not with these specific technologies, but and maybe not with, having ornamentation or something, but do you think that in 100 years, the technology would enable like construction of buildings that look prettier than modern buildings, but and also are more maintainable, or at least as maintainable? Or is it basically going to be steel and glass towers for the time, for the upcoming future?
Yeah, that's a good question. There's a lot of enthusiasm. Some of it is like architect driven, so we'll see how well it actually gets adopted. But for like more timber, large, tall buildings made out of heavy timber elements, I don't know if that will get, partially it's like an aesthetic thing, partially it's, the carbon, from a carbon perspective, right? It's using a lot of timber versus steel or concrete is like way, way better on that calculus. And it does kind of look nice. A lot of these like tech companies are building like these ornate timber offices and stuff like that. So that's like one trend. And then kind of, there's not like an obvious technology that could like usurp like the sort of standard palette we have, unless it's like a dramatic development of like material science or whatever, where somebody finds some way of building something that's, is way cheaper and gives you like way more options than you had before. Like that's, what like steel and then like concrete gave you, right? All of a sudden you could build things in ways that you couldn't do it before. Steel, because you could use so much less structure to build high, and then concrete because it was like liquid, so you could all of a sudden make any shape that you want, and that's when you get all these like really cool, interesting shells and really ornate concrete domes, stuff like that, which of course we also don't build anymore. So I don't see like an obvious like technology to kind of replace that. And then I guess, the other thing is like, when all of a sudden you had technology that could like easily duplicate or make any sort of art possible, right? Did that usher in a new era of like way better art or like 2D aesthetics? I don't necessarily think that it did, right? So I think if you could all of a sudden build any sort of shape that you want cheaply and easily, it's not obvious to me that would all of a sudden, okay, now we can get like really cool things. I'm sure you would see like a lot of interesting experiments on the margin or whatever, but it's not obvious to me that like the standard way of building, in some ways it might become even like less interesting, right?
So that raises the question of why we haven't seen in these other fields better aesthetics. So given how much you can do with artistic, like the traditional art today, why do these like paintings that are selling for millions of dollars look like, there's obviously the common perception and stereotype about them is that they're very like simple and ugly. And to apply that to architecture and engineering, there's this idea. Scott Alexander kind of talked about this a lot in his post, that there's this like cabal of modernist architects in these guilds who are just like very obsessed with building these buildings that the public doesn't like to look at. Given your exposure to the industry, do you think that's true, that like the architects are just have a completely different sense of aesthetics than the average public?
I think there's probably something to that in like where like you go to architecture school, and architecture school is like adjacent to art school, right? And you learn like, how to design buildings or whatever, but you also learn like a specific way of looking and thinking about them. And that like filters down into like how you design your building, something like that. But I think architects are, again, they are competing in a marketplace, and the vast majority of them who are not architects are basically having to deliver that buildings that owners like want and like and are happy with. And if they don't do that, they're gonna go out of business. I think most architects you will talk to will basically say, yeah, if I don't give the owner like a building that he's happy with, I am not doing my job correctly. And they're definitely, they're being hired for like there's among many other things, their like sense of taste, right? But perhaps that's part of the story. It's like a fragment or whatever. But I think would be very easy to over-index, and I think there's a lot of ways that's not true.
Okay. So I'm really glad we got a chance to cover this topic, and I appreciate all those explanations. But actually, there's one question that I didn't forgot to ask you last time that I'm curious about your opinion on. Is, let's say somebody listens to the conversation or they've been a follower of your blog, and this has got them interested in engineering. Somebody maybe in like high school or maybe early in college or something. For them to be able to do cool things in these fields in the future, what kind of training and career advice would you give them that they should pursue to be like get involved and innovate in these fields?
Yeah, that's a good question. I don't have a super good answer to that. I fell into it very much on accident. I spent the very large chunk of my career just doing, pretty standard workaday engineering type stuff. And then I sort of fell ass backwards into a job at a construction startup. And then that has sort of led me to other places. I guess, yeah, if you're an engineer, like go to a good, I feel sort of gross giving this answer, because in general, go to a good engineering school. It's like, you're, perpetuating the college industrial complex. But, people do really care about that, especially like in sort of the fields of, building engineering that I'm more familiar with. They do care about that quite a bit. I went to a reasonably good engineering school, and that probably opened doors for me that it would not have otherwise. So yeah, go to a good engineering school. Go to like a lot of like the status indicators that are like very obvious, like go to a good engineering school and go to like a top tier firm or whatever. That does kind of matter. People do pay attention to those things. I don't matter, quote unquote. It matters in the sense that people pay attention to those things in like the building development world. And then if you went to MIT or Caltech, and then you had an internship at Skidmore, Owen, Merrill or whatever, that's gonna open quite a few doors for you. I'm not amazingly happy with that answer. I do think that it is true. Yeah, another way would just be to try to come in from a more oblique angle, focus on like software and stuff like that, and then work at one of the because there's so many more startups and stuff that are now tackling the construction space. They're increasingly in need of like software developers and stuff like that. That would be probably a lower risk way to do it, because it's probably you don't need to necessarily go to a fancy school to become a software developer. And then if it doesn't work out, you can just go get a job at a FAANG company and make $600,000 a year. Yeah, look and see how like the startups in the space are changing and growing. I think by the time some folks got out, the building space might look pretty different in technology and software stuff is like kind of slowly forcing its way in there a lot more.
Okay. But then, so if they want to transition from just like being an engineer to working on the forefront stuff that you write and talk about, is working at a startup the ideal way to do that?
Oh, that's a good question. There's a lot of I think there's a lot of startups that are doing really interesting stuff, not just in software, but like a lot of interest in building technology stuff. There's a lot of like green building stuff that is being developed. Folks working on like low carbon concrete. There's like low carbon steels. Yeah, there's a lot of stuff doing like construction robotics, a lot of like prefab stuff. Startup world is really kind of trying to start to eat the construction world, and there's like a lot of opportunities there. I do, very broadly, I would say I see a lot of innovation happening. So I think that's a good place to sort of look and see what's going on.
Awesome. Okay, well, Brian, thank you so much for coming back a second time. I really appreciate it, and I'm glad we got a chance to talk about these questions, because it is very interesting, and it's good to get an actual engineer's perspective on it, so that we're not just doing like cultural theory and we actually understand the practicalities of what's involved and all these kinds of things. Okay, Brian, this was super fascinating. I highly recommend people check out your blog, which you can find at constructionphysics.substack.com. And they can also follow you on Twitter. We'll leave the handle in the description. Anything else you'd like to plug or say at the end?
I do. I'm doing some work for the Institute for Progress, which is a think tank designed to advance industrial progress and progress studies ideas more generally. So you should check them out as well.
Okay, excellent. Thanks, Brian. I appreciate it.
Yeah, thanks.
Hey, thanks for listening. If you enjoyed that episode, I would really, really, really appreciate it if you could share it. This is still a pretty small podcast, so it is a huge help when any one of you shares an episode that you like. Post it on Twitter, send it to friends who you think might like it, put it in your group chats, just let the word go forth. It helps out a ton. Many thanks to my amazing editor, Graham Bessalou, for producing this podcast, and to Mia Ayana for creating the amazing transcripts that accompany each episode, which have helpful links, and you can find them at the link in the description below. Remember to subscribe on YouTube and your favorite podcast platforms. Cheers. See you next time.